Now let's dive into the next topic, that is nothing but equipment for substations in the module 5. This is nothing but equipment for substations. In the substations, we are going to use different types of operators. Okay, the first one is main bus bars, reactors, substation insulators, switch gears, fuses, circuit breakers, power transformers, and then protective relays, instrument transformers, lightning arresters, indicating and metering instruments, and then finally batteries we are going to use in the substations. Now let's discuss one by one in depth. Okay. The first one is nothing but bus bar. Bus bar is a conductor carrying electric current to which many connections may be made. The function of bus bar is to connect switches and equipment in various arrangement. Bus bar may be copper, aluminum, or steel. The bus bars are used in substations are usually big rectangular sections bars or tubular form bars we can use. And due to economy in construction, high rate of heat dissipation, we are go for rectangular type of X section bars. Okay. Other shapes also can be used. In some arrangements, two bus bars are provided to which the incoming and are outgoing feeders and the principal equipment may be connected. One bus is called as main bus, other bus is auxiliary or transfer bus. Okay, in AC three-phase system, red, yellow, blue to indicate different phases. In DC system, bus bar as claret color, that is something called red, thick red color, and negative bus bar as blue color. Okay, reactors. Why we go for reactor? In order to limit the short circuit currents, to safeguard the value in order to protect the electrical installation. Ohmic resistance is comparatively low in reactors. According to construction, there are two types of reactors: open type construction, oil immersive type construction. First one is open type. In open type construction, circular coil are embedded to the concrete slab. Very simple in construction, but a few drawbacks like large space required, cooling difficult, and then limited to 33 kV. Suitable for voltage above 33 kV, we go for oil immersive type construction. That is, the cooling arrangement is similar to transformer. Based on the application reactor, we can divide the reactors into two types. That is, series reactor and then shunt reactor. Station insulators. Station insulator are used in generating station and substations to fix and insulate the busbar systems. They may subdivide it into post and bushing. A post insulator comprises of porcelain body, cast iron cap, and flanged cast iron base. Busbar connects through cast iron cap. Post insulator are available with round, oval, square, flanged base. This is nothing but a station insulator. First one, post insulator. Here, post insulator at the top, we can observe cast iron cap. In the middle, porcelain body, flanged cast iron base, we can observe. Okay, this is nothing but a electrical bushing type and purpose. Porcelain body and upper and lower locating washers and mounting flanges. Bushings are suitable for current rating above 2000 ampere. Okay, switch gear. Switch gears. What are the switch gear operators used for switching, controlling, and protecting the electrical circuit and equipment is called switch gear. The switch gear equipment is essentially concerned with switching and interrupting current, either normal or abnormal operating conditions. Switchgear is a very essential part for substation system. Two segments, switches and circuit breakers. Types of switches: air brake switch, oil brake switch, and isolators. Circuit breakers. We have different types of circuit breakers. What is the purpose of circuit breaker? It is used to interrupt the circuits while current is flowing through them. Thus, making and breaking of contacts in a oil type circuit breaker are done under oil. This oil serves a quench the air when the circuit is opened. Bulk coil circuit breaker is used when the voltage is up to 66 kV. For higher voltage SF6 or air blast circuit will be used. Circuit breaker. And then fuse. For fuse, we already discussed it in the module 2. You can go through the fuse. What is the definition of fuse and characteristics of fuse and different types of fuse with the help of for different applications. And then power transformer. What do you mean by transformer? Transformer is a static device which will going to transfer the electrical energy from one circuit to another circuit, which may change voltage and current but may not change frequency. Power transformer are used for stepping up the voltage for transmission and generating station and stepping down the voltage for further distribution at the main step down transformer substation. Power transformer, we have different types of power transformers for based on the cooling system. Natural cooling, oil immersed 10 MVA, air blast cooling above 10 MVA, forced oil and water cooling for very high rating. On-load tap changer used for regulating voltage. Transformer, we have two types, power transformer and distribution transformer. Power transformer to have maximum efficiency. So when we will going to get maximum efficiency at the condition of iron loss is equal to copper loss. Power transformer specification of power transformer kVA rating, rated voltage, number of phases, tapping, type of core, type of power or distribution, ambient temperature, type of cooling, voltage regulator, efficiency in percentage, PU or percentage. These are all the parameters are provided at the nameplate of the power transformer. Power transformer are generally installed upon length of the rail fixed on concrete slabs having the foundation of 1 to 1.5 meter deep. Okay, this is nothing but a protective relay. In the protective relay, we can observe sensing element, comparison element, controlling element to trip or circuit signal. This is the general typical circuit diagram of relay. We already observed in the power system protection. Here, in-depth analysis, we don't require. Just we need to observe what is the meaning of relay and what is the circuit diagram. That much is enough. And then protective device. Protective relay is interposed. Of course, protect relay is nothing but a protecting device. Protective relay is interposed between the main circuit and circuit breaker in such a manner that any abnormality in the circuit acts on the relay and it's open the circuit breaker to isolate the faulty element. The relay comprises of sensing element, comparison element, and control element. Instrument transformer. In the instrument transformer, majorly classified into two types, that is nothing but a CT and PT. AC type protective relays are actuated by current and voltage supplied by current and voltage transformer known as instrument transformer. The main function is to supply protective relay with the current and voltage magnitude proportional to those of power circuit, but sufficiently reduced in magnitude so that relays can be made relatively small and inexpensive. For safety purpose, secondary of CT and PT are grounded. Measuring instruments, current measurement for relay operation connected in series to the device. The primary winding of CT is connected in series with the load and carries actual power system current, and secondary is connected to measuring circuit or relay. Primary winding is usually single turn winding. The number of turns on secondary winding depending upon current to be carried by the power circuit. Current transformer. The ratio of primary current to the secondary current is known as transformation ratio of CT. Current ratio of CT is I. Secondary current rating 5 ampere, 1 ampere, 0.1 ampere, etc. Primary current rating 10 ampere to 3000 ampere. This is nothing but a CT. And then let's dive into the concept of PT. PT are employed for voltage above 380 volts, suitable for high voltage measurement and isolate them for high voltage. The primary winding of the PT is connected directly to the power circuit, either between phase and ground, depending upon the application. Secondary winding connected to the measuring device. Primary winding 400 volts to several thousand volts. Secondary to 110 volts. The ratio of rated primary voltage to secondary voltage is known as transformation ratio. This is nothing but a typical block diagram of the real-time block diagram of the potential transformer and then typical circuit diagram of the uh, potential or voltage transformer. Lightning arrestor. Why we go for lightning arrestor? It is a surge diverter and use it for the protection of power system against high voltage surges. It is connected between line and earth. Therefore, incoming light waves can be diverted to earth. Types: rod gap arrestor, arm gap arrestor, tyrate arrestor, expulsion type arrestor, and valve type arrestor. This is nothing but a lightning arrestor. And then indicating and metering instruments in ammeter, voltmeter, wattmeter, kWh meter, power factor meter installed in substations to control maintain the system. Batteries, operating control circuit, protective relay system, emergency lightning circuit powered by substation batteries. Type of substation batteries: lead acid battery and then alkaline batteries. Carrier current equipments. Carrier current equipment mainly used for communication system, for communication and controlling purpose. Switch add. And then this is nothing but a typical 33 kV substation single line diagram. Here you can observe 33 kV incoming line and isolator number one, 33 kV oil circuit breaker, CT and lightning arrestor. Here they are going to use one bus bar, 33 kV bus bar. From the 33 kV bus bar, they are going to divert the circuit into two circuit. There is nothing but a isolator 2, isolator 3. and then circuit breaker. This X mark represents circuit breaker, and then transformer. This symbolic representation represents primary star, secondary star. Okay, 5 MVA 33 bar 11 kV, same transformer 1, 5 MVA 33 bar 11 kV, transformer 2. From the transformer 1 and transformer 2, they are going to give another bus bar number 1, 11 kV bus bar. This is 33 kV bus bar. This is 11 kV bus bar. And then from 11 kV bus bar, they are going to give capacitor bank for improve the power factor. And then this is the incoming circuit. And then from the 11 kV bus bar, here they are going to give auxiliary transformer for the substation power supply. And then 11 kV potential transformer they are going to use. Potential transformer always connected in parallel. So that's why one is connected to primary is connected to one terminal is connected to bus bar, and then another is connected to ground. Okay. From the 11 kV bus bar, they are going to give outgoing feeder, that is feeder number 1 for consumers, feeder number 2, and then feeder local industries. This is something with local industries from other side of bus bar 11 kV bus bar number 2, and then for out feeder number 3, and this is incoming feeder number for rural area 1 and then rural area 2. These are all this is nothing but a single line diagram of 30 kV substation. And then second one, 66 kV substation. From the 66 incoming line, they are going to use main isolator switch and then bus bar. And then from the bus bar to isolator to oil circuit breaker, circuit breaker to isolator, lighting arrestor, and then 66 bar 11 kV transformer. From 11 kV transformer, they are going to directly connect it through the CT to 11 kV bus bar. From the 11 kV bus bar, they are going to give to the outgoing lines 1 outgoing 2, outgoing line 3, and then capacitor bank outgoing 4, 5, 6, 7, and then two station transformers 11 bar 0.433 kV transformer, and then another connection from 66 only 66 bar 66 isolator. Here you can observe this is nothing but 11, this is nothing but 66 only. From 66 to they are going to use 33 kV light arrestor. 33 kV they are going to use. Okay, this transformer will going to convert from 66 bar 33 kV. Why? Because some applications will require 33 kV. So that's why they're going to give. Here you can neglect this part and then you can write down only this part. Okay, that up to you. Okay, and then single line diagram of 220 kV substation. Of course, 220 kV substation, two feeders are coming for the incoming. We're going to get two bus bars, two feeder, sorry, feeder number 1 and feeder number 2, and then bus bar 1, bus number 2, bus bar 3, and then bus bar RYP. Okay, and then here they are going to use two transformer. Okay, 100 MVA, 100 MVA transformer each, 220 bar 132 kV, 220 bar 132 kV, transformer 1, transformer 2, and then 132 bus bar 1, bus bar 2, bus bar 3. From here to we are going to give another type feeders. Okay, and then bus coupler from 11 133 32 33 kV transformer 132 33 kV, and then from 33 kV to outgoing feeders. Okay, this is nothing but a three single line diagram. You can write down one time, you're going to get the clear picture of the single line diagram of the different types of substation: 33 kV substation, 66 kV substation, 220 kV substation. Among these three substation, in your examination you will going to get 100% one question. Okay, and then a substation auxiliary supply. In substation, small amount of power is needed for electrical lighting for during regular periods of inspection, maintenance, and repair. Electric power required for auxiliaries, lighting circuit, air blast fans of power transformer, battery charging set, oil service facility, ventilating fans, water supply, and heating system. Supply needed for synchronous condensers. In large substations, it is wide practice to connect two transformer. Okay, this is not about auxiliary supply, actually substation for auxiliary supply single line diagram. So 11 kV bus bar 1, 11 kV bus bar 2. Here we need to connect one isolators and a circuit breaker isolator CT, and then transformer, that is something with 11 kV bar 433 volt transformer from here to auxiliary supply. Okay, and then substation earthing by using horizontal mesh or of horizontal mesh of steel rods vertically electrodes welded to mesh. Here we have two types, two parts of earthing system: an underground horizontal earth mesh known as earth mat or earth grid or earth electrode, earth risers, and earthing connections. Several identical earth electrodes are driven vertically into the soil and are welded to the earthing mesh at the one end and brought directly up to the equipment or structure foundation. This is nothing but a substation earthing. Okay, per conductor, earth mat, ground level, GI wire. Okay. Earthing risers are usually mild steel rod bent in vertical and horizontal shapes and welded to earth mesh at one end and brought directly up to the equipment or structure foundation. Earthing connections are galvanized steel strips, step potential and potential touch potential. Step potential, touch potential. These topics are very important. Okay. Step potential is potential difference between a feet of the person standing on the floor of the substation with 0.5 meter spacing between 2 feet. Therefore, through the flow of earth fault current through the grounding system. Okay. And then touch potential is the potential difference between the figures of raised and touching and the faulted structure and feet of the person standing the substation floor. The person should not get shocked even if the grounded structure is carrying fault current. Step potential and touch potential should be as minimum as possible. Earthing mat is the number of rods joined together through copper conductor. It reduces overall ground resistance. This is nothing but an example for touch potential and step potential. This picture represents 0.5 meter between 2 feet. That is nothing but a step potential. And then here person is going to touch the pole. That is nothing but a touch potential. Okay. Need for substation earthing. Why we require earthing substation gap ಬೇಕು. Safety of operational and maintenance staff, discharge of electrical charge to ground, grounding of overhead shielding wires, electromagnetic interference, and then let's solve one problem, okay, in the next video.